All right, let's continue on and see how to find inverses algebraically. So, and then graphically. So if I have a function that it is 1-to-1, f of x equals x minus 9 over x plus 9. So let's just skip to show that it is 1-to-1 because it's a little more complicated. And we are asked to find the domain of f. Well, f of x is a rational function, and we know that we can't have the denominator equal to 0, so that means that x plus 9 cannot be equal to 0, which means that x cannot be equal to -9. And then in interval notation, yes to everything but -9. So the domain of f is just going to be -infinity to -9, union -9 to infinity. Now, can we find the range of f without graphing it? No, just by looking at the function, I can't tell what the range is. But if I find f inverse, I know that the range of f is equal to the domain of f inverse. Because of what we said on the previous note right here, that the range of f is the domain of f inverse. So if I find the inverse, I can get its domain, and therefore I'll get the range of f. So let's find the inverse of f. So I need to find f inverse of x. Okay, so the steps. Okay, so step 1, rewrite f of x equals x minus 9 over x plus 9 as y equals x minus 9 over x plus 9. So that's the first step. Instead of f of x, I'm going to write it as y. Step 2 is, we know that the inverse and the function switch domain and range, so they switch input and output. So basically I have to switch x and y. Switch x and y. So instead of y, I'm going to put x, and instead of x, I'm going to put y. All right, then step 3 is solve for y. So I need to solve for y in here. So I can write x as x over 1, and then I can cross multiply. So it'll be x times y plus 9 equals 1 times y minus 9. So xy plus 9x equals y minus 9. I'm solving for y, so I'm going to bring all the y stuff on the left-hand side and the other stuff on the other side. So I'm going to have xy, I'm going to subtract y from both sides, so minus y, and then subtract 9x. So minus 9 minus 9x. And then we're going to factor out the y. What I have left from this one is x, and then minus, I have left a 1. And then I'm solving for y, so I need to divide by x minus 1 both sides. So y is going to be -9 minus 9x divided by x minus 1. So this is our inverse. Step 4, rewrite as instead of y, you're going to put f inverse now. So f inverse of x equals whatever you got y to be. So this is the inverse. This is how we find the inverse algebraically. Now, can you find the range of f using the information we have about f inverse? Yes, because the range of f equals the domain of f inverse. And if I look at f inverse, the domain is going to be everything but what makes the denominator 0. And what makes the denominator 0? well, x minus 1 cannot be equal to 0, gives me that x cannot be equal to 1. So that means that the domain is going to be everything but 1. So it's negative infinity to 1, union 1 to infinity. So you see, I couldn't find the range of f just from looking at this without graphing it to see what are the y's. But if I find the inverse, you know how to find domains easily. So if I find the inverse, the domain of the inverse is going to be the range of f. Okay, so this is how to find inverses algebraically. Graphically, how do we find the inverse graphically? So if I have a one-to-one function, then f of x equals y for any x in the domain of f, and f has an inverse f inverse. So what do we mean by that? Well, if I have a point AB on the graph of f, then what's going to be a point on the graph of f inverse if they switch the domain and the range? So that means that I switch. This is for my x and this is for my y. So if I switch them, this is going to be my x now and this is going to be my y. So a point AB on the graph of f is going to be become a point BA on the graph of f inverse. So what we say, sorry, I have it in color in here. So what we say is that the graph of f inverse is obtained by reflecting the graph of f in the line y equals x. It's where y equals x is this line right here. It's a line with slope 1 and y-intercept 0. So y equals 1 times x plus 0. So it goes through the origin and it has a slope of 1. So if I have a function f, its inverse, f inverse, is going to be, I take the line y equals x and I reflect f over that line. So a point right here, let's say a point right here, AB, is going to become a point BA on the graph of f inverse. So let's see what we mean by that. So I'm given the graph of this, and I know it's a one-to-one function, so it has an inverse. So this is f, and I want to get the graph of f inverse. So let's see, I have this point right here. This point right here is negative 4 for x and 0 for y. And then I have a point right here, 0 for x and 2 for y. So this point 0, 2 is going to become 2, 0 on f inverse. So if I have 0, 2, the point 2, 0 is right here. So this point right here is going to go right here. So the point 2, 0. And then this point negative 4, 0 is going to turn into 0, negative 4. So 0 for x, negative 4 for y. So this point is going to go right here. So how do I draw this? I only have 2 points now. So let's draw the line y equals x, and that's going to help us. So y equals x. So now I can see that this reflected by y equals x is going to go here, and this reflected by y equals x is going to go here, and then this reflected by y equals x is going to go there. So it's going to be something like, so this going to be like that. Oh, God. And then this portion right here is going to be like that. Okay, so this is y equals x. My function f, the blue one, was this, and then I followed some points. Reflection by y equals x is going to give us f inverse. All right, so let's do some applications with inverses. If I have that at a local pizza parlor, the daily special is $12 for a plain cheese plus $2 for each additional topping. Let call the topping x. So find the function f that models the price of a pizza with x toppings. So f of x is going to be, you pay $12 for the base and then $2 for each topping. So it's going to be 12 plus 2x. So if I have no toppings, then I'm just going to get a plain cheese pizza and it's going to be $12. And if I have one topping, it's going to be 12 plus 2 and so on. So for f, the input is the number of toppings. The input is x, the number of toppings. And the output is the price. So now for f inverse now, let's see what f inverse will represent. So f inverse, the input for f inverse is the output of f. So the input is going to be the price. And then the output is going to be the number of toppings. So we can find the inverse, f inverse of x. We can just do let's do the steps. So step 1, instead of f of x equals 12 plus 2x, I'm going to write it as y equals 12 plus 2x. Step 2, switch the x and y. So instead of y, I'm going to put x, and instead of x, I'm going to put y. Step 3, solve for y. So that's going to be 2y equals x minus 12. So then y equals x minus 12 over 2. So and this is my inverse now. Step 4, that the inverse is x minus 12 over 2. Now, if a pizza costs 22, so that tells me that I am given the price. So if the price is 22, how many toppings does it have? So if the input is the price, 22, and I gotta solve for the output, that means that I need to use f inverse. So f inverse of the input is price and is 22. So f inverse of 22. F inverse of 22 is going to be 22 minus 12 over 2. That's 10 over 2, it's 5. 5 what? 5 toppings, right? So this is what that means. If given the price, how many toppings? So F inverse calculates that. One practice exercise. We're asked to find to graph the function 9 minus x squared. 9 minus x squared is the parabola. Well, x squared is like this. Minus x squared is reflection over the x-axis. And then 9 means up 9 units. So I'm going to take this one and move it up 9 units. But let me erase this first. So it's going to, let's say this is 1, 2, 3, this is 9, let's say. So this is the point 0.9, and this is, well, the x-intercepts are 3 and negative 3. So this is the function 9 minus x squared. Find its inverse. Is 9 minus x squared 1 to 1? Does it have an inverse on its entire domain? No, because it does not pass the horizontal line test. But if we restrict the domain, then we can find its inverse. So let's write in here. So f of x equals 9 minus x squared is not 1-to-1 on its entire domain, but it is on, let's say, from 0 to infinity, so half of it, from 0 to infinity. So let's just erase this portion of it, because I'm only interested in the portion of the domain where the function is 1-to-1. Okay, so there you go. I have my function. F, this is f on 0 to infinity. Let's find its inverse algebraically and then graphically. Okay, so algebraically, I have to keep in mind that the domain is restricted, so x is greater than 0. That's what it means, that the domain is 0 to infinity. So algebraically, to find the inverse, instead of step 1, instead of f of x equals 9 minus x squared, step 1 is writing it as y equals 9 minus x squared. Step 2 is switch x and y, so I'm going to have x equals 9 minus y squared. Step 3 is solve for y, so I'm going to have that y squared equals 9 minus x. I just rearranged to solve for y, and then I'm going to take square root of both sides, and don't forget my plus or minus. So plus or minus square root of 9 minus x squared minus x. So notice that when I first started, I had to have the restriction that x is greater than 0. But when I switch the x and y now, what was the restriction? Instead of x now greater than 0, I'm going to have y is greater than 0. So this is going to tell us now that we're going to pick the positive one, because y has to be greater than 0. So y equals square root of 9 minus x, and this is our inverse. Step 4, this is the expression of the inverse. Square root of 9 minus x. Okay, so algebraically we found the inverse algebraically. Now let's do it graphically. So remember, graphically, if I have a point on f 0, 9, what's going to be the point on the inverse? Well, it's going to be 9, 0. So if this is 3, this is 6, this is 9. So this point 0, 9 is going to go to the point 9, 0. And then the point 3, 0 right here is going to go in the point, so this is the point 3, 0. So it's going to go to 0, 3. So this point is going to go right here. Okay, let's draw the y equals x quick. So I know that this is going to go here, this is going to go there, and then this is going to go here. So my inverse is going to be like this. So this is just this portion. If I want to draw this left one, I just need to continue right here. So this is f inverse. Alright, I hope this makes sense. You guys have lots of practice with the homework.